Okay, today's lesson would be 2-7, so graphing absolute value functions. And so yesterday we talked a lot about parent functions. So an absolute value parent function would just be y equals the absolute value of x, because that is the most basic form of an absolute value function. So we mostly just did sketches yesterday. Today we're going to formally plot the points and get a better picture of where this is at. So we are going to first graph the parent function by making a table, and then we'll put it on our graph. A couple little vocabulary things. So a vertex will be the minimum or maximum point for these graphs. Remember, they make a V-shaped graph, so that would have a possible minimum, or if it's flipped over, a maximum. We'll also talk about the axis of symmetry, and that's the vertical line that is going to go through that vertex point, and that's going to split your graph in half and then be symmetric on each sides of that line. All right, so in your homework, you will also have to make tables. They're going to give you your x values, and then you're going to type in what the y values would be, and then you're going to match those graphs. So typically, the problems that I saw in Math Excel, they used -3 up to +3. So that's what I'm going to demonstrate in this example. So I'm using the parent graph right now. So when I test -3 in for x, I'm taking the absolute value of -3, which remember would be a +3 because it is that distance from 0. So it's always going to come out positive. And then next I'm testing -2, which would be +2, and -1, which would be 1. And the absolute value of 0 is 0. And the absolute value of 1 is 1. Absolute value of 2 is 2. Absolute value of 3 is 3. Okay, and then I'll go ahead and plot these points on my graph. So my x is -3, my y is 3 for the first point. My second point, my x is -2, my y is 2. My next point, my x is -1, my y is 1. And then I've got 0, 0. All right, then +1, +1, +2, +2, and +3 and +3. And there's that V-shaped graph that we saw yesterday when we used either our graphing calculator or we used Desmos.com. Okay, and it would continue forever and ever if I kept plugging in more values of x. Okay, so right here is the vertex. So when it's the parent function 0, 0 is my vertex. Okay, that vertex is that, in this case, a minimum point. Okay, and then to the left of the vertex and to the right of the vertex, they're symmetric. So if I drew a line through that vertex, a vertical line, that is your axis of symmetry. So what's nice about that line is when I know the point on this side, I know the point to match on the other side because they are symmetric and they're matching in the same locations on the opposite side of that line. Okay, so that's the basics of our parent function. Let's take a look at the next two examples, and we're going to make a table and sketch of the graph. Now I want you to think about what we learned from yesterday, even before you make the table, and just kind of think about the transformations and knowing what that does. Okay, the hope is that right now when you look at that and it says the absolute value of x and the +2 is at the end, that you know that that means this graph is moved up 2 from that parent function that we just drew. Okay, so that would be shifting everything up 2, and then we'd have that V-shaped graph. Okay, that's what it will look like after we make our table. But if you already have that understanding, it'll definitely help you knowing if you made any mistakes in making the table and the sketch. So I'll go ahead and start with the first x value. So absolute value of -3 would be +3 plus 2 is 5. Next, absolute value of -1 plus 2 would be +1 plus 2 is 3. Next is 0. Absolute value of 0 would be 0 plus 2 is 2. And then 1, absolute value of 1 is 1 plus 2 would be 3. And then the last one, absolute value of 3 is 3 plus 3 would give me 6. So then I'm plotting those points. So the first point I got here is -3, 5. The next point is -1, 3. And then 0, 2. 1, 3. And 3, 6. Oh, I put a +3 here when it should have been +2, and that would be 5. Whoops. So one thing I was noticing is it should have been symmetric on the other side, so that's how I knew I was wrong here. All right, so we make that nice V shape. It's what we expected would happen. Everything moved up 2 from that 0, 0 point. So that is my new vertex location. And then that axis of symmetry, that invisible line that's splitting your graph in half so that you can see that the points are symmetric on the other side if I've found the points correctly. Okay. For the second problem, number 2, so here I have that +2 on the inside. So if you remember when it was on the inside the absolute value bars, it's going to move kind of the opposite direction that you would expect. We're moving left and right, but the plus is going to move this left too in its transformations. Okay, that's what we saw when we did a lot of graphing with our calculators and Desmos. Okay, we're going to plot, or we're going to plug those points in and then kind of actually see how this works, so maybe a little bit better than what we saw yesterday. So if I start with -3, I'm taking -3 plus 2 first. So that gives me -1. What is the absolute value of -1? It is +1. So what students do incorrectly is a lot of times they understand that when you take the absolute value of something, it's positive, but sometimes they try to take the absolute value of -3 first. Okay, that's what I had to do over here. I took the absolute value first because that was the only thing that was in there, and then I added 2. Now I am adding these things together first, and then I'm taking the absolute value. Okay, these two equations are different, and they're going to create a different graph. Okay, they both have absolute values, and they both have a +2, but in different locations, and that's important to pay attention to. All right, so then for plugging in -1, -1 plus 2, I do that first, so -1 plus 2 is just a +1, and that absolute value would be 1. 0 plus 2 would just be the absolute value of 2, which is 2. And then 1 plus 2 would be the absolute value of 3, which is 3. 3 plus 2 would be the absolute value of 5, which is 5. So then I'll plot my point. So -3, 1, -1, 1. And 0, 2, 1, 3, and 3, 5. Now this graph looks goofy because I'm missing a very important point to kind of I'm missing the vertex on this graph because I didn't use it. So this isn't a great example, but in Math Excel, this is kind of what they do. They make you put those points in, and sometimes they're not the best. I really should have -2 in here, because if I did -2 plus 2, I would get 0. And so -2, 0, there's my vertex. Okay, so then it's going to, if I match the points on the other side without even plugging them in, I know that's what's going to be happening. Okay, So if you see, this graph has moved left 2, which is what we expected from the very beginning. So there's the new location for my vertex. And I can use that invisible line, like I said, to help me plot points on each side of that line. Okay. All right, so now without graphing, let's try to identify the vertex, that axis of symmetry, and then the transformations of each of these functions. Okay, when we look at them, we want to be able to do this without making a table every single time. You certainly can if that helps you and you're having trouble with that, but the hope is that you could come up with the vertex, your axis of symmetry, and the transformations. Okay, the transformations, I sometimes actually like to do that first. So when I see inside of the absolute values, that's shifting it horizontally. But if it's a minus, I am moving right. So right 3. And then the +1 after the absolute values would mean up 1. So my vertex, if I'm moving right 3, up 1, would be the point 3, 1. The axis of symmetry is going to be the line that goes through that vertex. All right, so it's going to go through the 3 because it is a vertical line. So if I look back at these other equations here, this is the line that went through the point 0, 2. So it goes through the x. This would have been the point -2, 0. So it would have went through -2. And if it's a vertical line, I only write x equals because it's never crossing y. So I'd say x equals 3. That is the equation of that line. Now, if you just write 3, it's going to be marked wrong because 3 is not an equation of a line. X equals 3 is the equation of the line. Okay. All right, for number 2, let's find the vertex. Axis of symmetry for short here, and transformations. So I like to find the transformations first. I see that 3 multiplying on the outside, that is going to give it a vertical stretch. Okay, it's a stretch because it is a number that is larger than 1. It'd be a compression if it would be a number between 0 and 1. Okay, so it's going to stretch it because you're tripling those values. And then nothing on the inside, so we're not shifting anywhere left or right. So that means you're staying at 0 for the x coordinate of your vertex, but you're also going down 6. So that would mean my y coordinate is -6 since I had to move this whole graph down 6 spots. That axis of symmetry is a vertical line, like we said, so it must say x equals, and it goes through that x coordinate of the vertex to split that graph in half. For number 3, once again, we'll find the vertex, axis of symmetry, and then our transformations. The negative out in front, that is going to be a reflection over the x-axis. The 1/2, that is a number between 0 and 1, so that is going to be a vertical compression. And then that +10 is on the inside, so that means we're moving left and right, but the plus would move it left 10. Okay, so I'm going left 10, so -10 is that starting point. Nothing there to the right, so 0 would be the y coordinate of that vertex. Axis of symmetry must be written as x equals, and then it's going to go through -10 as the x coordinate. All right, one last example here. So in this problem, we're going to find the vertex and the x and y intercepts if there are any. Okay, so hopefully the vertex is making some sense at this point. This tells me I'm moving right 5 up 2. So my vertex would be 5, 2. Now I'm trying to find the x-intercept and the y-intercept. Or there could be more than one. Okay? Now you need to remember what x and y intercepts mean. So on a graph, where you cross the y-axis would be a y-intercept. Where you cross the x-axis would be an x-intercept. And you need to think about, as a point, there would be an x value and y would have to be 0 as the x-intercept. As the y-intercept, your x is 0, and then you have that y value. And so that's the information you're going to use to help you figure this out. So my x-intercept, if I'm trying to find that, I need to plug 0 in for y. So 0 equals -2 times the absolute value of x minus 5 plus 2. So now we're solving that equation for x, and we are working on this the other day. So I'm going to subtract 2. Right, I'm trying to get the absolute values by itself, divide by -2 on both sides. Okay, now I have a +1 equals the absolute value of x minus 5. Okay, before it might have looked like we were going to have a no solution situation since I had an absolute value equal to a negative number, but I can't make that decision until the absolute values are isolated and alone. Now this is not an absolute value situation. Once the absolute values are by themselves, set it equal to 1 and +1. Sorry, 1 and -1. So when I add 5 to 1, I get 6. When I add 5 to -1, I would get 4. So that means I have 2 x-intercepts. When x is 6, I get 0, and also when x is 4, I get 0. So that means on my graph, 1, 2, 3, 4, 5, 6. 6, 0, and 4, 0 would be 2 x-intercepts. Okay? And then my y-intercept then would mean my x value is 0. What is the y value? This is actually a little bit easier to figure out than the last problem here. So I'm plugging in 0 in place of the x. So now I don't have to solve it. I'm going to just evaluate. So what is 0 minus 5? That's -5. What's the absolute value of -5? That's +5. -2 times 5 would be -10. Plus 2 would be -8. Okay. So down, let's say that's -8, is where you're crossing the y-axis. That's your y-intercept. We figured out the vertex would have been 5, 2. This graph is reflected, so here's a rough sketch of what's happening. I've got my x-intercepts and my y-intercept. Okay. It's possible you might not have x-intercepts. Okay, if this graph, if the vertex was somewhere above or below the x-axis and it would never actually cross it, then you're going to get a no solution situation on an equation. Okay, so I like this problem because it's applying a lot of different things we've talked about so far, and we're going to continue to talk about x and y intercepts with other graphs. But this is probably going to be one of the more difficult problems on your homework. So please reach out if you're having trouble. But that is it for our lesson today.